All right, this will be our first lesson video for Unit 1A, 1A.1 over vocabulary. All right, as we begin lesson 1A1, vocabulary and notation, I want to introduce what geometry is really talking about here at the beginning. We're talking about the understanding of how things are arranged in two-dimensional space, and those spatial arrangements and those spatial relationships help us develop the math behind geometry. And so before we begin into some of those relationships, we have to define some basic terms, some basic ideas and basic building blocks, and how to kind of speak the language of geometry. So as we begin, we're going to start with some vocab. So our first thing we're going to look at is called a point. Now, I think a lot of you know what a point is. Okay, a point is just something that looks like this. You might call it a dot. But a point we represent on paper with a dot, but we name it by a capital letter. All right, and so we would just call this point A. That's how you name that. But the features of a point is that it's a location. So because it's just a location, it's an identified place, it has no size or shape. You can't measure a point. Now, it could be an ordered pair, x comma y, and we could give it a location specific to an x-axis and a y-axis. But for the most part, we're just dealing with points out here in space like this. So anytime I have a point with a capital letter, and I take another point, so I'm going to do my point A there again, and I'm going to do another point, let's call it B, and I connect those with a linear path, or a line, that goes on forever in both directions, that becomes a line. Okay? And we name a line either by two capital letters or a lowercase script letter. Lowercase script letter. Okay, and so here's what that looks like. Okay, this could either be called line AB, and so we put the two capital letters with a line notation above it. Or if I add in this script letter, like a cursive L, the word script kind of just means cursive, I could also call this line L. Now, a line is made up of all the points on that linear path. It has no thickness then. Okay, we can't measure the thickness, and it really doesn't have length because it goes forever in both directions. Okay? But as soon as I identify what a line is, there's actually two other terms I want to consider, and that is portions of lines. Okay, and these two terms here are going to be portions of lines, meaning they're part of a line. A ray has one endpoint, so I'll go back and I'll use my A there. But then it has an arrow at the other point, or actually through the other point. So this one endpoint is where my line stops, but it goes on forever in the other direction. This is what a ray looks like. Now, because my endpoint is at A, okay, and the arrow is by the B, we still name it with two capital letters, but the endpoint goes first. And the direction is important, so I would call this ray AB, and you use the AB and then a ray symbol to the right, so only one arrow. That's how you name a ray. It starts at a point and extends forever in the opposite direction. But then another portion of a line is when there are no arrows. It's just the two endpoints. Okay? I can make that look a little bit better, sorry. Okay? And it's named again by two capital letters. And a segment notation above it. So I'll label that. We would call this segment AB. With a segment, no arrows, just a segment symbol. It's supposed to be a straight segment there, no curve. Now, this can stand alone or could be within a line. What that means is this is standing alone. This is part of a ray. And then this segment AB is still part of that full line. Okay? All right. Then when I take lines and points and I start to arrange them together, we get some different terms. One of the most important ones we can look at is what an angle is. We're going to talk a lot about angles. This is what an angle looks like. Okay? It's a triangular shaped space formed by the intersection of lines, rays, or segments. So I'm going to draw a line, and from a point on that line, I'm going to draw a ray. Okay, and really, if I think of it as two rays, that might be easier. It's easier to look at. That is one way to look at an angle, but it's not just those two rays. It's all the space in between them. Okay? That space is the angle. Okay, now the way we name an angle, there's a couple different ways. One way is just to assign it a number. If they just give you like a number, I can call that angle 2. And it would look like this. Angle symbol, there's your symbol for angle, with a 2, if it has a number. If it does not have a number, though, there's a more formal way of identifying and naming an angle. And that is using 3 capital letters. Okay? And so we have to have the points to identify those capital letters. So if I gave this point value an A, and I labeled this point B, and this third point C, I would call this angle A, B, C. The middle letter here is the vertex of the angle. Where the two lines, rays, or segments intersect is called the vertex. That always has to be the middle letter. Okay? And we measure an angle in degrees. And so angles are going to take a little more clarification as we work with them later on because there's a lot of math involved with angles. There's also a lot of math involved with segments. But to finish up and have one more piece of vocab, we're going to talk about what a plane is. And this is not as in the word airplane. This is plane as in a flat surface, okay? It is a flat surface made up of points. Now, it's also going to have lines and segments and rays as part of that sometimes, but it's going to look like this, okay? So I'm going to draw this shape, which technically I'm drawing a parallelogram, but it looks like a kind of tilted or slanted rectangle. All that does is allow me to see this two-dimensional flat surface, kind of like a sheet of paper, as if it's laying down at an angle, kind of. That's all that really does. Mathematically, or sorry, artistically, we would call that perspective. Okay, it looks like we're away from this a little bit. Now, we have to assign some more values to it. Now, there's 2 ways you can name a plane. The easiest way, the shortest way, is by giving it a capital script letter. So I'm going to call that R, like a kind of curvy or cursive letter R, capital letter. There's our bell. And so I would call that plane R. Or you could use 3 non-collinear points. And I'm going to explain what the phrase non-collinear means in just a minute. But 3 points that are not lined up in a straight line. Kind of like 3 points in an angle. Even if the segments are not drawn, I can name that then, instead of calling it plane R, I can call it plane A, B, C. And it doesn't matter what order you write those letters in. Okay? Oops, let me go back. All right, so as we have finished up our notes there for that page, we're going to move on to the next part of the notes. And we're going to identify and label some geometric elements you see in this photo. All right? Now, I'm going to give you some time, and as we watch these lesson videos, what I usually have you do to save time in the video is to pause the video at certain points and try and do things on your own. And then when you click play on the video, I'll show you what you should get or some examples of what you might get. So this is one of those times. What I want you to do is maybe pause this and look at the screen for a little bit and see if you can identify and label correctly things that would be points, segments, planes, etc. in this photo. And then even asks, are there any lines in the photo? So this is a good time to pause. If you need more time, go ahead and keep it paused or pause it again, but now I'll show you some examples of what you might have. All right, these are some examples of different elements you might see. These blue lines here, okay, these are segments. I'll make them purple, I guess, maybe. These are segments. Anytime those two walls might meet, those kind of form segments. Now, we do actually have something you could think of as a line. All right, these lines that kind of go off into the distance kind of forever, those perspective lines, if you've ever taken three-dimensional drawing classes, that's a line. Now, I've highlighted what might be planes. All right, so this red region here on this right side, that wall could be a plane. The floor, highlighted in yellow there, could be a plane. Or even just a partial plane here, this what looks like the top of the fireplace, that mantle area, that could be a plane. Even this flat section here of the fireplace, that mantle itself is a plane. All right, so as we continue looking at these ideas, you know, you're going to start noticing some of these things kind of around your own rooms or wherever you are. You can start to notice these ideas. Well, we're going to look at some new terminology that helps us relate these figures together. And I mentioned the phrase non-collinear earlier in the notes. So we're going to identify what collinear and non-collinear mean. Okay, so right here, this first word, collinear, refers to points being on the same line. Co meaning with or together, linear meaning on a line. So any points that line up on the same line would be collinear. Okay, because it always takes at least 2 points to make a line, we never want to really say that 2 points are collinear. It needs to be at least 3 to consider collinear or non-collinear. So if you have 3 points that don't line up in a single straight line, those would be non-collinear. All right, and we'll do some examples in a minute. So the same ideas with these 2 words here, or phrases, coplanar and non-coplanar. Any points that are on the same plane would be coplanar. Any that are non-coplanar would be where not all of them are on the same plane. And you need at least 4 to identify them as non-coplanar, because any 3 points, we could connect them with one plane. So what we're going to do is we're going to sketch some examples. I'm going to do a couple of these with you, and then I want you to try some on your own. So first one, number 1, we're going to do together. If I ever go too fast, you're welcome to pause the video and get caught up. So as we look at number 1, it says to draw segment AB. This notation up here means it's a segment containing point C. But it also says point D is non-collinear to points C and B. So let's just start one piece at a time. We know we're going to have a segment with some points. That's the only words that we've used. I haven't used the word plane, haven't used ray, haven't used line, haven't used angle. We're just using a segment with points. So I'm going to start with segment AB. So I'll draw A, pick some other place for B, connect them with a segment. And it needs to contain point C. That word contain means that C has to be somewhere along that segment. Because this is a segment and there are no points outside of A or B, C has to be somewhere on that segment between them. It doesn't have to be the exact middle. Okay? If I just use the word between or contains, it doesn't have to be in the middle. It just has to be somewhere along that segment. But then it says point D is non-collinear to points C and B, meaning it should not be on that same linear path. So if I put point D there, that's a no-no. That's wrong. In fact, I'm going to get rid of that. D needs to be somewhere else. So I'm just going to pick a point that is nowhere in line with that segment at all and put point D. It doesn't have to connect to it. It is just a separate point. Okay? So let's try number 2. Number 2, this would be read as angle XYZ formed by ray YX and YZ. That means this Y value is your vertex. I want you to label it like that. vertex, V-E-R-T-E-X. So that's what I'm going to start with, even before I read the rest so that it doesn't get confusing. I'm going to start with that. I'm just going to draw an angle, and the ends of the angle have arrows because it's formed by rays. Ray y, x. Y has to be the vertex down here, so I'm going to make x up there. Notice that I have to put a dot for the x. I can't just label the arrow with an x. I have to actually put a dot. And then yz means this other ray is yz. Yz and yx. Then it says that point M is collinear with points x and y. So it's on that ray xy somewhere. So I'm going to put another point. I could be between there, or I could be outside if I left room, but it needs to be on that ray. So there's M is collinear with x and y. And point N is collinear with y and z. So on the other ray, there goes an N. So our drawing should look something like that. Okay? Now, I want you to try, I'm going to get you started on number 3, but I want you to try and finish it on your own. So it says to draw plane R, and that should be a kind of script letter R. It just didn't print that way in the program I was making this with. So we're going to draw a plane. Just draw this kind of rectangular region. Make it look a little slanted if you can. Doesn't have to be perfect. Okay, we're going to label that plane R. And now it contains point A. So that means somewhere on that plane, we got point A. I'm going to let you do that. Then do points A, B, and C. We don't want two different point A's. These are the same point. Don't do two different A's. Just do the same point. Then also add B, C, and D that are coplanar but non-collinear. All right, it might look something like this. I've got 4 points, A, B, and C, and D, that are coplanar. They're all on this plane together, but they're non-collinear, meaning they don't line up in one line. Now, I've had students in the past say, well, Mr. Allred, these line up in a line, but not all 4. When it says A, B, C, and D are non-collinear, that just means all 4 are not on the same line. All right, I want you to try number 4 on your own, and then I will show you what that might look like. If you need more time, pause the video, but this is something similar to what you should have on it. All right, we've got plane S, and point V is on plane S, but point W out here is not. Okay, let's go to the next page. I'm going to finish up with a little bit more information. A lot of information here. A lot of information. So we're going to get started with some other terminology. So types of linear relationships is important. When we have these lines or parts of lines that are related, there's 3 basic ways they can be related. We could have 2 lines that are intersecting, okay, which just means that intersecting lines meet at a point. And so there's only one point that the 2 lines have in common. Okay, then we have parallel lines, which means this, that parallel lines never intersect. Parallel lines never intersect, so they have no points in common, and so we show them this way. Okay? Now, there's also some notation we give for that. If 2 lines are parallel, we mark them parallel with kind of these matching arrows. Okay, chevrons, or make them little triangles if you want sometimes, but that's how we show those 2 lines are parallel. And then we also have lines that we consider to be perpendicular, which would be this. Perpendicular lines intersect at a right angle, or a 90-degree angle, and we show that with this. Okay, we add the 2 intersecting lines. In this case, I've got a line along the bottom, then a ray coming up from it. But this box right here that we put in that angle shows that it's a right angle, a 90-degree angle. Okay, so we're going to practice drawing some of these. Okay, to draw the intersection of 2 lines, we just draw one line and another one. I'm even going to label where they intersect. Okay, I could call that point, let's call it T. I could also name the lines, like line N and line T. Kind of a curved or italicized type of writing. Okay, to draw the intersection of a plane and a ray, is a little bit different. So I'm going to draw a plane first. Draw your flat surface. And to show that it is intersected by a ray, meaning the ray crosses the plane, it's not drawn on the plane, we're going to show a dot for that point where the ray comes off of the plane. Think of it as a piece of paper with a string coming up above the paper from that dot. It would look like that. Okay? If I were to want to draw a plane intersected by a line, I would do the same thing, but because the line continues forever, I would use a dotted line to show that it goes below the plane like that. Okay, that's if we change the problem to say line instead of ray. And then we would label the point and the ray and the line accordingly. All right, to draw parallel lines, we're going to do this, kind of like the example I gave you. Draw two lines that go alongside each other. We're even going to put our notation to show that they're parallel with the two matching arrows. But the notation would be this. Okay, let's say I called this line L and line T. To show that line L is parallel to line T, I would write my L, and then I would use this symbol for parallel lines, and then put T. I could also call this line, instead of line T, I can call it AB. And instead of line L, I could call it line CD. And I could say CD is parallel to AB. But you have to put the line notation above. Okay, to draw parallel planes. That one's a little bit trickier. We're going to draw one plane, kind of flat, and then underneath it, I'm going to outline the edge of another plane, and to show the overlapping part, we're going to use dotted lines like that. And it kind of looks like one piece of paper hovering above another one. And so if I called the top one plane R and the bottom one plane Q, I would say plane R is parallel to plane Q. All right, let's keep moving right along. A little bit longer lesson at the beginning here. To draw perpendicular lines, we've done that before. Okay, let's call one of these line T, and let's call the other one line X, Y. So at that point Y there, these two lines are perpendicular, so I need to add that right angle box. And the notation for that, we would say line T, or just T without the word line, is perpendicular to, and this is your symbol for perpendicular. It's an upside down capital T. There's two perpendicular lines like that. And then we would say line XY above that. All right, and finally we want to be able to draw perpendicular planes. That one's a little bit harder to do. So we're going to have our kind of horizontal plane going this way. To show that it is perpendicular, okay, I'm going to kind of draw a dotted line through the middle like that, because here's what we're going to do. We're going to draw that plane coming up above and down below. Okay, and so it's kind of like I've got these two pieces of paper that cut through each other along this line. That's a little bit confusing to look at. I can give you more examples later if you need help with that. And again, if I called one of them plane T, let's call that plane T, and plane R, I would say plane T is perpendicular to plane R. All right, as we go through this, I'm going to give you some examples, some other examples of how to draw from some given statements. So number one here, we are going to show plane E contains segment AB and is intersected by ray CD at point X. So the first thing we're going to do is draw a plane and label it plane E. You can do a cursive E, or just a kind of slanted letter E, and that's fine. We want to show that it contains segment AB. So along that plane, I'm going to put points A and B connected by the segment. But the plane is intersected by ray CD. So ray CD is going to come up off of the plane, but the point where it's intersecting is actually point X. Now, it can be both the segment and plane intersected, or I could put point X over here. It doesn't really say. So I'm going to put point X over there on the plane, and above the plane, that part of the ray goes up, and below the plane it has to go through because the end point of ray CD is point C, and another point on that ray is point D. So we're kind of showing that ray goes up through the paper. Okay? On number 2, we don't have to draw a plane. We're going to draw ray XY, that's a ray, and line AB are parallel. Okay, so notice I've used AB twice. Well, I don't want to do two different segments calling them AB, or two different lines. I want to do one line AB. And I'm going to draw ray XY parallel to that. So there's my X, there's my Y, and they are parallel, so I'm going to mark them parallel with my arrow notation. But we also have AB is perpendicular to segment ED. So I'm going to draw a segment going through AB, call it ED, and put a right angle box to show that they're perpendicular. That's one way you could make that drawing. Okay? I'm going to quickly show you possible drawings for 3 and 4. Pause the video again and try and do them yourself if you want, or just pause the video and copy them down. But to save some time on the video, we're just going to show the examples quickly. Then you should be able to start the assignment. Okay, there's number 3. And yours might look a little different than mine. It might be turned one way or another. And there's number 4. Make sure that you don't have multiple points with the same letter and same label. Okay, same thing for segments and rays and such. All right, you should be able to start the Pear Deck assignment for 1A.1 now.